Hi folks. Alright, so today this video is really just a brief video to cover summarizing the forms of, most specifically, a quadratic equation or function, which, by the way, its shape is called a parabola. That gets a little confusing. The function is a quadratic, that's what its equation is called, but the shape is called a parabola. So it's like the equation gets a name and what it looks like gets a separate name, but they go together. Okay, so here's the situation. There are three equations that you might come across when working with a quadratic. The first one, standard form, is when you've got the function and it has its individual terms written out in descending order. Okay, so notice that you've got your degree of 2. Ax squared is that leading term, right? We've got our leading coefficient. That's a. Bx, c. Okay, so what's the advantage or usefulness of this particular equation? Well, the biggest advantage is the c value. 0 comma c is actually the y-intercept, okay? Otherwise, standard form could possibly be helpful because you could set it equal to 0 and solve in a variety of manners to find the x-intercepts. But the most useful part is really what's above that. Find the y-intercept is pretty direct from standard form. Okay, vertex form. That's when you've got a function equal to a times x minus h squared plus k. All right, now I want you to notice leading coefficient, same situation. The a value in every variation of the same quadratic is going to be the same a value. Same a value because it's just different forms of the same equation. Now, the important or useful thing from this function is the h comma k. That is your vertex. All right? Vertex form, this is most useful for graphing. Okay? That's really what you want. If you're going to graph something, you want it in vertex form. All right, and then factored form. Factored form, man, solving is a breeze when you're in factored form. Okay. R stands for root, okay, as in 0, as in x-intercept. All those things are synonyms. So, R could be the same number, could be different numbers. It just depends on the polynomial, the quadratic that you're looking at, right? It's totally changeable. So R1 and R2 could actually be the same number. Could be two different numbers. Could be a positive and a negative, whatever. But the key thing is that A, still the same. So if we're talking about the same quadratic, standard, vertex, and factored form will all be like equivalent forms. So the A value is the same. What is the benefit of being in factored form? Identifying the x-intercepts. That is super fast because you just set each factor equal to 0 and solve. All right? When you solve them for x, you get your x-intercepts. So, how are these different forms helpful? Well, for example, if you take a look at this equation in number 5, I've got these two x-intercepts, and I know this vertex. So right off the bat, I know that I could write f of x equals, so this is at -1, -4. This is at 1, 0, -3, 0. Okay, so I could write something times x plus 1 squared minus 4. And if you're wondering why I changed that to a positive, it's because technically this is x minus -1, which switches it to a positive. Okay, so that's why in summary, this is a positive 1. And then for factored form, f of x would equal something, we don't know what a is yet, times x plus 3 times x minus 1. Okay, because it's always x minus the root. So minus a negative would be a positive. Okay, So the A value. Now the reason why I haven't done standard form yet is because I need one of these. And then I'm going to multiply it out to get me standard form. So first idea is that it could just be 1, like the A value could be 1. If A is 1, then when I go 1 unit over, I should be 1 unit up. That looks true. And if I go 2 units over, I should be 4 units up. Also true. So looks like our A value is 1, which means I'm going to take factored form. So f of x equals x plus 3 and x minus 1. I'm going to multiply these two things together. So I'm going to get x squared minus x plus 3x minus 3, right? Because I distribute every term to every term. So my function is going to equal x squared plus 2x minus 3. And if you'll notice, the y-intercept tracks. It matches with my graph. Okay, see if you can do number 6, and then you can check your answer back here with me in a moment. Welcome back. All right, so the factored form. Oh, and by the way, in this first problem, or that we did like number 5, this example, we know A is positive because the polynomial, the quadratic, has up arrows at the end behavior, so we know that the leading coefficient has to be a positive number. So same thing here, and it looks like it's probably going to be 1. So we're going to have x minus 1 times x minus 3, because we're at 1 and 3 for our x-intercepts. F of x is going to equal 1 times, and you don't have to write the 1 here. I'm just writing it so you don't forget that, like, identifying the A value is a thing, right? Okay, what do we got? We got x minus 2 squared minus 1, right? Because this ordered pair is at 2 comma negative 1. That's where that guy is. And so just to mix it up a little bit, I am going to use the vertex form to find standard form, just so you can see what it looks like to multiply this one out. So I've got 1 times x minus 2 squared minus 1. Okay. Most common mistake is that people forget that this squared means that there's 2 x minus 2 factors. So I just wanted to remind you that that's a thing. So we're going to get x squared minus 4x plus 4 minus 1. So we should get x squared minus 4x plus 3. And notice now we have a positive 3, and that matches up. It's just good to check to make sure that all the math works out, because it should. Everything should fit together really nicely, like a puzzle, like the final pieces of a puzzle coming into place. If something doesn't match up, then there must be some fact or detail that maybe is missing, or possibly just has the wrong sign. So you just want to make sure that you're paying attention to all those different details along the way so that everything all fits together and aligns. All right. Thanks so much for listening. That's all I've got for you on this. Have a good one.